talk about, everybody knows. There's something in the middle that you might not be as familiar with. But anyway, that's what we're going to do. Okay, the first one's the addition property. Okay, and the addition property allows you to add the same thing to both sides of the equation. And it doesn't change it. Okay, it keeps it balanced. So like if A is equal to B, then you can add C to both sides. A plus B equals B plus C. If you were going to solve this equation over here, what would be the first thing that you would do? Add 2 to both sides, right? The addition property allows us to do that. Okay? The second one is the subtraction property. Just like the addition property, it allows us to subtract something from both sides of the equation. So looking at this one.
Just for an interruption. Ladies, some of you wanted to come in and listen to Mrs. Christian talk about Miss Oklahoma scholarships that are available through that, and also Miss Washington King. You can leave right now to come down to the North Commons. She will speak to you there. Please bring a pencil or pen with you. So you can write. But come right down. It will last the rest of the hour. Those of you that are coming down. So let's get to the North Commons right now. Thank you.
Okay, so this one, what would we do to solve it? Y plus 6 equals 11. What would we do? We would subtract 6 from both sides. Okay, so you subtract the same thing from both sides of the equation. Alright, then we've got the multiplication property of equality. It allows us to multiply both sides by the same thing. Whatever you do to one side, you gotta do to the other. Okay, so what will we do to solve this? X over 5 equals 2. Multiply both sides by 5. So that's the multiplication property. And the division property, same thing. It allows us to divide both sides by the same thing. Keeps it balanced. What would we do here? 7y equals 42. You would divide each side by 7. So that's relatively easy. Now, these next ones you may not be as familiar with. And this first one here is the reflexive property. And the reflexive property basically just says A equals A. 2 equals 2, PQ equals PQ. Okay, we don't use it a lot, but you might be asked to identify it. It's like looking in a mirror and you see yourself. Okay? So that's the reflexive property. The next one you use all the time, you probably don't realize it, but it's called the symmetric property. And basically what it allows you to do is if you've got A equals B, it allows you to flip it and write B equals A. If you solve the equation and you end up with your answer being 2 equals X, when you go to write your answer on the line or the answer column, what do you typically write? X equals 2, right? Well, that is the symmetric property. Okay? Here's another example. This one in regard to line segments. AB equals CD, CD equals AB. They just flip places. That's the symmetric property. Now, the next two people tend to confuse a little bit, so we'll make sure we get this straight. The transitive property is very similar to the law of syllogism. Okay? And, you know, the good cheese comes from happy cows come from California, good cheese comes from California. Except instead of if-then statements, it's about equal signs. So if A equals B and B equals C, then A equals C. That's the transitive property. The order here is very important. It has to hook together like a train. Okay? So A equals B and then B equals C, so then A equals C. Okay? Here's the example in regard to line segments. If AB equals CD and CD equals A, then A equals A. Okay, that's the transitive property. It's very similar to the law of syllogism. Then we've got the substitution property. Okay, the substitution property says that when you've got two things that are equal to each other, you can replace one with the other. And let's say you're going to make muffins, and you wanted to be healthier if you're going to eat a muffin. Instead of using oil, what can you use? Anybody know? Use applesauce. Okay? So if you want to do a healthier muffin, you can replace the oil in the muffin mix with applesauce. And it would be not as, it would be lower fat. Okay, so here, if you have AB equals 7 and CD equals 7, you have two things that are equal to the same thing. AB and CD are both equal to 7. So if that's true, then those two things are equal to each other by substitution. Okay, substitution. It looks like transitive, but the order's not there. You see how the order's not there, like it is in the one above? Okay, with the transitive property, the order has to be there. And then we have the distributive property. And the distributive property If you have A times the quantity B plus C, you take and distribute A times B plus A times C. So over here, if you've got 3 times the quantity x plus 5, that's 3x plus 15. Okay, because you distribute. Okay, so we're going to look at these properties, and we're going to identify them. What you want to do is you want to look at the if, and what did they do to the if to get to the then? What did they do to the hypothesis to get to the conclusion? Okay? If AB plus BC equals DE plus BC, then AB equals DE. What did they do to the if to get to the then? Any ideas? This is what I ended up with. AB equals DE. What did they have to get rid of or do? No, not the transitive, because the transitive property is like 3 equal statements. What did they do? They had to get rid of stuff. In the end, the AB and the DE are equal to each other. What did they get rid of? You see how you get rid of it? You subtract it, right? Because they're both added to it. Okay? So we can subtract BC from both sides, and that ends up being AB equals DE. Does everybody see that? Okay, that's subtraction. Okay, here's another one. If xy equals PQ and xy equals RS, then PQ equals RS. Yes. That is substitution. See, you've got xy is equal to PQ, and you have xy is equal to RS. You have xy equal to 2 different things, okay? Or the 2 different things both equal xy. You can think of it like that. And so since they're both equal to the same thing, they're equal to each other. Okay? And so that would be substitution. Now, I don't care if you use abbreviations. Just be careful that we can distinguish between subtraction and substitution. You have to use more than just sub. Okay? Alright, here's an easy one. What do we do to solve this guy? How do we get from here to here? Multiplication, right? Multiply both sides by 3. Multiplication. Okay, what about this one? Measure of angle ABC equals the measure of angle ABC. That is reflexive. It's like the mirror image. If 2x equals 9, then x equals 9 halves. Division, good. Okay, how about this one? Measure of angle 1 equals the measure of angle 2. The measure of angle 2 equals the measure of angle 3. And the measure of angle 1 equals the measure of angle 3. That's the transitive property. You see how the order is there? Okay, so we're going to do our first couple of proofs here, okay? So the 2 column proofs and algebraic proofs are a little easier. When you do a proof, you have a given and you have a proof. You always start out with your given, that's your first step, and then your proof is always your last step, okay? And you make a little T-chart. One side says statements, the other side says reason. And again, you always put your given as the first step. 3 times the quantity, x minus 5/3 equals 1. And your reason would be that it's given. And what we're going to do is we're going to solve this equation, and for every step that we do, we're going to justify it, okay? Alright, so what would be the first thing we would do here? Distribute. So we do 3x minus 5 equals 1, and that's the distributive property. Then what would we do? There is subtraction there, but to solve it, you would add. So we'd add 5 to both sides, so we get 3x equals 6. That's addition. So we always do the opposite operation. Okay? And so then what would we do? We divide both sides by 3, and x equals 2, and that's addition. And so then we get down to the end, and look, our proof is there, isn't it? Okay? Alright, so we stepped it out logically, and we came out with our answer. Everybody's first and last statement should always be the same, okay, as far as the statements are concerned. Your reason on the bottom one will be different every time. Okay, here's another one. First thing we write down is the given. So we have 7 halves minus 10 equals 4 minus 1/2 n. Yeah. Another thing you need to recognize is that your proof might look a little bit different than your neighbor's. It depends on what path you take. Okay? Because everybody solves equations differently sometimes. I mean, there's a general direction, but sometimes some people do things before others. What's the first thing we should do here? Yes. Multiply both sides by 2. I'm going to actually show this multiplication. Because it really is 2 steps here. It's 2 steps because we multiply both sides by 2, but then what do we have to do? With the 2 that we're multiplying, what do we have to do? We have to distribute it. So you want to show each one of your steps. So you know 7 minus 2n equals 8 minus n. And that will be the distributive property. Now at this point we might take different paths. I'm going to show you one way, then we're going to talk about another way that it could be done. Okay? At this point, if it were me solving it, I would add n to both sides. Okay? So that would give me 7 minus n equals 8 by addition. Then I would subtract 7 from both sides. That gives me negative n equals 1 by subtraction. And then I would divide both sides by negative 1. And that would be division. And I'm done. That's what I'm trying to prove, is that n is equal to negative 1. Now, I'm going to show you an alternate way. And you don't have to show this unless you want to. I'm going to erase this part. Okay, at this point, did anybody think add 2n to both sides? Anybody think to do their equation like that? Not one person. You did? Okay. Alright, so add 2 into both sides. If I did that, it would be 7 equals 8 plus n by division. Then I would subtract 8 from both sides. Negative 1 equals n by subtraction. Now, remember, I want my final step to say n equals negative 1. So, I can flip-flop that. What's that called when I do that? That's the symmetric property. And so that's an alternate way it could have been done. We basically solve the equation. It's just, some people choose to do some things before others. Okay? Alright. So, we have a worksheet. Now, there's quite a few questions, but I'll be honest with you, my last hour I had several people finish. Okay? Because they're real quick to sitting the problem. Okay? They solve a few equations that are not really hard. So I'm going to pass you down just a couple of things I want to show you. I'm sorry. Okay, on 1 through 23, these are basically just identify the property like we did in the notes. Okay? Then you go down here to the bottom. It says give a reason for each step. Now this one's already been worked out for you. So you're just going to, write down. What's the first step always? The first step of your proof is always the given. And then what do they do to get to the next step? They add. There's subtraction there, but you have to do the opposite operation. So you add, and then what they do? They divide it, right? Okay? So that's all you have to do on those. Now when you flip it over, the next few problems, it's telling you what property to use. You're not identifying the property. They're saying, okay, I want you to use, let's look at number 27. I want you to use the symmetric property. So it says if blank equals blank, then the measure of angle RST equals the measure of angle JKL. What goes in my if blank equals blank? If the measure of angle JKL equals the measure of angle RST, then the measure of RST equals JKL. You might want to go back and reread it and make sure that the property makes sense. Okay, and so then you go down a little bit further, and there's 2 more equations like we're on the front where you have to justify the reason. And then you have 4 where You just have to solve it. Okay? Your first step will be to give it, and then you work it out. Okay? And your whatever X is your answer at the end. They didn't actually tell you what to prove. If you have two subtraction steps together, I don't care if you do them both at the same time, but if you have a subtraction step and then an addition step, they have to be two separate steps. Okay? And I think on this one, they combined multiplication and distributive, which I don't really like you to do that, but I just thought this worksheet off something, so they have to do that. Okay? All right, any questions? All right.